Hello, and welcome to the Sleepy Professor. Find a place that feels safe and steady, where you can sink a little deeper into stillness. Let your shoulders fall heavy, let your breath soften, and let the weight of the day slide quietly to the far edges of thought. Tonight, we'll wander together on a slow, restful path, into the gentle shapes of nothingness and the subtle rules that cradle them. Before our walk begins, a quiet question. Where are you listening from? Perhaps a high window in a city, where distant lights blink like stars. Perhaps a small country room, where the air already smells of night. Or perhaps beside the hush of a real shoreline, where the waves already carry their lullaby. Wherever you are, let that place keep you company now. And if these whispered reflections bring you ease, a soft tap on like and subscribe is always a kindness. To those who already support this quiet little corner of thought, thank you. You help keep it gentle, you help keep it calm. This time together is meant to be just enough, a touch of curiosity, a faint spark of wonder, wrapped in words slow enough to ease you towards sleep. And if some thought lingers, let it be light, like a feather resting until morning, softened, ready to carry only peace. So, as the room finds its hush, and your breath finds its rhythm, here is the pebble to hold in the palm of your mind. Can nothing have a shape? At first, nothingness seems only an empty word, yet philosophers and scientists have long painted it in many shades. To a philosopher, nothingness is pure absence. No space, no time, no matter. In physics, the vacuum is never truly bare, but a quiet stage where invisible fields wait and sometimes ripple. In mathematics, emptiness has its own symbols. The empty set, the zero, the thin thread of a line, the still point from which all distances radiate. Tonight's journey follows how even these whispers of nothingness reveal a structure, and how geometry, distance, angle, connection, becomes a soft language for silence. Our pace will be slow, gentle, unhurried. We shall begin with the earliest thinkers, who spoke carefully of the void, and of what cannot be seen. They sat with silence, listening not only for what was there, but for what was absent. The quiet edges of reality, the invisible frame behind all form. Then we shall wander toward the birth of zero, that small and mysterious circle, so light it could almost be breath, yet so heavy it reshaped thought forever. Zero gave a place for absence, a mark for nothing, a stillness made visible on the number line. It taught counting to pause, to recognize the gap between footsteps, the hush between notes of music. With zero, emptiness was no longer exile. It was a home, a station, a presence in mathematics itself. From there, we still enter Euclid Sepp's quiet garden, where lines and triangles grew like orderly vines. Their relations tended with the patience of a monk. Here, the calm rules of a flat world were drawn, a stage of still geometry, where parallel lines, forever stubborn, whispered of the possibility of bending, hinting that space might hold secrets beyond flatness. Then curves arrive, like rivers softening stone, the gentle sphere, where a straight path always returns home again, like a traveller circling back at dawn, and the restless saddle, where lines part endlessly, like companions strolling slowly in different directions, through a park at dusk, never to meet again. This gentle path leads us towards space-time, a world where gravity ceases to be a pull, and becomes instead a bending, a soft folding of the stage itself. Here, every motion is guided, not by invisible strings, but by the quiet hand of geometry. Closer still, we meet the quantum vacuum, a silence trembling with unseen possibility. At our scale it is stillness, but beneath, it quivers like a drumhead just barely touched, ready to sing though no note is yet struck. Further on, topology opens, a way of seeing shapes that stretch and breathe, where edges matter less than connections, where a coffee cup may, with patient hands, be reshaped into a ring. Here, form becomes playful, and the measure of shape is no longer corner or curve, but whether one surface may flow into another. Then symmetry arrives, soft and solemn, whispering promises of balance. It is the grammar of nature sips rules, the hidden rhyme scheme of the cosmos. Symmetry steadies, so that when one thing shifts, another answers, a call and response, woven into the fabric of being. To rest the mind still more, we could pause with art and with architecture. Negative space dot the pause in a painting, the wide margin of a manuscript, the silent nave of a cathedral, teaches us that absence can cradle meaning, that emptiness can be as eloquent as form, and finally, the path will widen toward the stars themselves. The horizon stretches, the galaxies drift, the universe flows like a slow tide, and we are invited to wonder, is it endless, or simply a long circle, a path that one day will carry us quietly back to where we began? Each thought will be placed gently, like lanterns set one by one along a night path, and if your attention drifts, the path will remain lit enough to return. The goal is not to solve, but to soothe, to feel by the end that even when nothing seems to exist, there is still a gentle shape to the silence, and knowing this is enough to rest. Picture a quiet room at dusk. The walls are plain, the air still, the silence feels almost tangible. Without edges, the hush might go unnoticed, but with a frame around it, the silence takes on a kind of shape. Philosophers began with this intuition. Perhaps what we call nothingness is not truly a thing, but the frame that allows us to notice. From this soft beginning, ideas grew, some bold, some cautious. In ancient Greece, one voice denied the void entirely. Parmenides spoke of what is, whole, unchanging, indivisible. If nothingness is literally nothing, he said, then it cannot be thought, cannot be spoken of, and cannot exist. For him, reality was seamless, a stone sphere smooth to the touch, without crack or hollow, without gap or void. Others, the atomists, dreamed otherwise. Leucippus and Democritus imagined tiny indivisible atoms, drifting in the emptiness. Without the void, they said, motion could not breathe. The void was not a thing in itself, but the open stage, where all motion played its part. Where Parmenides sealed the world shut, the atomists opened it wide, letting movement flow in. Two visions, one austere, denying emptiness, the other playful, insisting on it. Their tension shaped centuries of thought, and always, it seemed, sometimes the stage was as important as the actors. Aristotle, ever cautious, leaned toward fullness. He believed motion required a medium, something present to carry it. A true vacuum, he argued, would birth troubling paradoxes, speed without limit, motion without measure. The cosmos, for him, was like a vast sea, where every motion was a push and a yielding. Space was not a container waiting to be filled, but the natural order of bodies, resting in their places. And so, the story of nothingness continued, passed gently from hand to hand, softened, reshaped, returning in new forms. Philoponus, centuries later, let his thought drift against the current. Where Aristotle saw every motion needing a medium, Philoponus wondered, might movement persist on its own? As though guided by memory, he planted the first seeds of inertia, not loudly, but with the quiet courage of someone placing a small lantern on a long road. In the medieval Islamic world, these questions found new caretakers, great scholars and theologians, inheritors of Greek texts, opened Aristotle's Sips pages, like gardeners tending an old stubborn tree. They studied with reverence, yet also with questioning, grafting new branches, weaving ancient thought into living tradition. Some lean toward atomism, tiny sparks forming reality, but their vision reached further than Democritus. Shaped by faith as much as reason, Avicenna sat with patience, contemplating continuity, place, and whether the void could truly exist. Averroes, equally devoted, wrestled with Aristotle like a beloved teacher, respectful yet unafraid to argue. Their work was not only science, not only philosophy, but a weaving of reason with devotion, a meditation on creation that sought to honor the Creator. Later, in medieval Europe, voices like Jean Buridan and Nicole Orozmi picked up the thread. They let impetus grow, slowly loosening the chain that tied motion to medium. They began to clear a small meadow in thought where the idea of a vacuum might rest more comfortably. In monasteries, in universities, and in royal courts, the debates moved gently like candlelight flickering across stone walls, and at the heart of their discussion sat a single soft question. Could God, if he so willed, create a perfect vacuum? Even if nature seemed to resist it? For them, the vacuum was not only physics, it was theology, philosophy, devotion, it was faith and reason braided together in hushed voices. Centuries later, experiments with mercury columns and barometers revealed the weight of air itself. Emptiness, once a thought experiment, began to appear in glass tubes and quiet laboratories. Yet even those discoveries were only possible because the soil had been long tilled by ancient debates that refused to let the idea of nothing vanish completely. Aristotle's full universe was not the only vision. Another Greek whisper lingered. This time from the Stoics. They imagined a cosmos breathing with divine spirit, filled with energy and life, yet they too made room for the void. For them the world was whole, but it floated in unbounded emptiness, surrounded by silence. The void became like the white margin around a poem, not empty in despair but necessary. Giving the words space to sing. Far beyond Greece, other traditions shaped nothingness in gentler tones. In Buddhist thought, emptiness did not mean a hollow vacuum. Instead, it revealed that no thing stands apart, self-sufficient and unchanging. Everything arises in relation. The mantra form is emptiness. Emptiness is form, was not bleak but compassionate. It reminded us that things are waves, always rising and falling, always connected to the same sea. In Taoist writings, the same insight breathes. The wheel turns because of the empty hub. A room is livable because of the space it holds. The absence, the hollow, the silent core. Et is what gives function meaning and ease. Emptiness is not loss, but use, not void, but gift. None of these traditions solved the physical vacuum, but all of them softened the imagination. They made nothing less rigid, less harsh, and more inviting. Step back, and the pattern unfolds like a slow mandala. For some, nothingness was a contradiction, a logical impossibility. For others, it was the quiet background of all change, the stage on which movement could appear. For still others, emptiness was not a threat but a gentle invitation to notice relationships, not essences. To value the open margin as much as the ink. Think of a quiet room. Its silence is not defined by what fills it, but by its edges. By walls, by doorways, by the open floor. Without boundaries, there would be no sense of silence at all. Emptiness is framed, and the frame gives it meaning. And this gentle insight mattered deeply for science. Every theory needs to ask, where are things and how do they move? If space is full dot. If it is a plenum dot, then motion must always be pushes and pulls, like boats drifting in a crowded harbour. But if space is void, then motion can stretch through emptiness itself, guided by invisible laws, by force, by the quiet geometry of the unseen. To treat emptiness as describable dot, not mystical, not forbidden dot, was to sharpen thought. It invited practical questions. How does pressure shift in a sealed space? How does light glide across emptiness? How does a falling object trace its curve through the air? Each question nudged the hand toward drawing diagrams, toward building instruments, toward careful measure. Yet beyond science, there was also a softer gift. The centuries-long conversation about nothingness taught minds to notice the fine grain of distinctions, to see that absence is not always negation, to weigh contradiction against possibility, to sense how a single assumption, whether the void exists or not dot, could ripple outward and change the whole view of the universe. This quiet discipline of tracing consequences would one day become the sharpest tool of mathematics and physics. The debate about emptiness always carried a quiet demand. Be clear with words. Be gentle with intuition. Notice the frame as carefully as the picture inside it. If nothingness could still hold a shape, then perhaps silence too could carry a structure. And if silence could have a structure, then perhaps absence itself might be a presence soft comma, unspoken, but felt. So once again we step back into that quiet room. It greets us not with what it contains, but with what it refuses to impose. Its gift is not in the objects set within it, but in the spaciousness it leaves open. A doorway marks a passage, not because of its wood, but because of its empty gap. A window frames a view, not because of its glass, but because of its openness to light. An empty floor does not push against you. It invites you to step, to cross, to move. Emptiness, far from being bleak, becomes a kind of gentle invitation. An invitation to walk, to see, to rest, to breathe. And in this way shape is born not from what is full, but from the tender edges of what is not. To speak of emptiness, reason itself grows softer. It reaches not for heavy words, but for symbols. A point that marks absence, a cross that shows direction, a number that anchors a line. And here, quietly, almost like a whisper, 0 appears. Picture again the still pond at night. The water does not move, the air does not stir. It is a place where sound has paused, where motion has folded inward. From its calm centre, ripples might one day drift outward but the centre itself remains unbroken. 0 is that centre. Not a loud splash of number, but the stillness from which all numbers radiate. To understand how this symbol of nothingness first came to life, we must wander back through time. We walk past scribes, hunched over clay. We pass astronomers gazing at unfamiliar stars. We listen to patient philosophers wondering how to mark what cannot be marked. Slowly, carefully, they gave nothing its shape. In the vast river valleys of Mesopotamia, mathematicians pressed wedge-shaped signs into soft clay. Their system was built not on 10 but on 60, an elegant base for the rhythms of astronomy and the exchanges of trade. Yet they faced a puzzle that seemed simple but was not. How do you distinguish between 1, followed by emptiness, and 1 followed by fullness? How do you write the difference between 1 with nothing beside it, and 1 with something beyond it? Their answer was not yet a number, but a placeholder. 2 small wedges, pressed carefully between digits. A pause on the page. A deliberate silence. Not 0 as we know it, but a whisper of 0. It was nothing written as something. not yet a participant in calculation, but a guardian of rhythm, keeping place, holding space. Centuries passed, and on the Indian subcontinent, the idea deepened. Here, mathematicians began to treat zero not just as a placeholder, but as a number of its own. In the 7th century, Brahmagupta gave it a voice in arithmetic. He described what it does and what it leaves untouched. Add zero and nothing changes. Subtract it and the quantity remains. Multiply by zero and everything folds back into stillness. Division was more delicate, less certain, but the leap had been made. Nothingness was now invited into arithmetic's conversation. From India, this quiet traveller journeyed outward. Scholars writing in Arabic and Persian carried it with them across deserts and seas. They gave it a name, Jafir, meaning empty, a word that softened through Latin into Zephyrum and then into zero. Al-Khwarizmi explained its use with care. Merchants marvelled at its efficiency. Astronomers found their calculations cleaner. Accounts grew faster, clearer, less prone to error. And yet, in medieval Europe, the curved numerals met suspicion. Some cities banned them in official ledgers. Authorities feared their soft loops could too easily be altered, unlike the rigid strokes of Roman numerals. But convenience is patient. It waits. It seeps slowly into the hands of craftsmen, the ledgers of merchants, the lessons of scholars. Fibonacci, returning from his travels, became its advocate. He showed its usefulness, and little by little, resistance thinned. Workshops opened their books. Universities taught the new numerals. Merchants welcomed the speed. And zero entered the rhythm of everyday life. Once adopted, it revealed itself as both tool and anchor. In positional notation, a digit's worth depends entirely on its place. A 2 in the ones place is 2. In the tens place, 20. In the hundreds place, 200. Zero keeps the places honest. Remove it, and meaning shifts. Insert it, and an empty column gains weight. As an additive identity, zero whispers, change nothing. As a multiplier, it hushes all quantities into silence. These simple rules gave arithmetic its reliability. Merchants welcomed it. Astronomers trusted it. Mathematics itself breathed easier. And now, let us return once more to the pond. Lay a slender stick across its surface. Use it to mark a line. At its centre, place zero. From this still middle, distances extend in opposite directions, one way and the other, positive and negative, forward and back. This is the number line. So familiar to us now, it feels inevitable. But once it was a revelation. Zero is no longer only a mark. It is a location, a point from which distances radiate, a centre that turns numbers into directions. Cross two such lines at right angles, and they meet in calm. That meeting point becomes the origin of a plane. With two numbers, every point can be described. With three, all of space opens up. Equations and shapes merge. Algebra and geometry clasp hands. And all of it rests quietly upon a single point, called zero. But zero is also more than a centre. It is also the idea of approaching. Imagine placing a leaf upon the pond. It drifts, slowly toward the middle. It may never touch the exact centre, yet it always moves closer. This is the language of limits. Quantities drawing nearer and nearer, describing behaviour at the edge of nothingness. Ancient geometers worked with patience, approximating areas and lengths. In the 19th century, this language grew rigorous. Mathematicians measured closeness itself, not assuming infinite smallness, but describing careful approach. The infinitely small has its own long, curious story. Philosophers once wondered whether space and time divided endlessly, or whether they ended in indivisible fragments. Early modern mathematicians spoke of indivisibles, tiny quantities whose squares could be ignored. Newton and Leibniz used infinitesimals, nimble shadows to trace slopes and curves. Later analysts preferred limits, precise and safe. And in the 20th century, new systems arose to allow infinitesimals to exist consistently, at last marrying the dream of the infinitely small with the rigor of analysis. Zero, then, was never only a mark. It was always more. It became a still center, a place of balance, a gentle companion for numbers, a calm boundary for limits, a patient partner in the slow, careful description of change. And through it all, zero remains what it has always been, a silence that gives shape, a nothing that allows everything, a center from which the universe can be measured. It is the soft language of limits. When we drift towards zero, or imagine steps that are small, yet never vanish, the mind learns a delicate way of speaking about edges, about corners, about the smooth turning of curves. And why does this matter for the shape of emptiness? Because zero shows us how to cradle nothing without breaking its silence. As a placeholder, it holds meaning, gently keeping places in order. As a number, it behaves in stillness, giving arithmetic a neutral rest, an anchor for multiplication. As an origin, it offers a single peaceful point from which all directions gain clarity. And as a boundary approached in limits, it gives scale to refinement, letting descriptions soften as fine as needed. All of these roles, woven together, allow empty stretches of line, plane, and space to be described without ever being filled. The quiet grid that names points does not weigh the space it maps. The axes that meet at zero do not clutter the plane. Even the idea of near zero sharpens thought without disturbing the air. Picture a radial image. Circles, perfectly round, gently centered on the still origin. Each circle, a soft ripple at equal distance from the calm point. This is another language of clarity. Polar coordinates, where a point is described by how far it drifts from zero, and by the angle it makes with a guiding line. Again, zero is not absence. It is the quiet center of reference. Whether the grid is square or round, the purpose is the same: to let emptiness carry structure, while remaining hushed and open. The mind learns something soothing here. That order can exist without filling every space. That naming point does not mean crowding them with weight, and that the most meaningful point of all might be the one that marks nothing. This gentle trust transforms how we solve. Curves soften when their distances from zero are known. Balance steadies when gains and losses rest evenly around the center. Change becomes easier to sense when tiny steps measured against zero whisper how steep a climb or how gentle a slope. Whether sketching a simple line or describing a winding motion, zero is there, like a silent conductor of a slow orchestra, keeping time, aligning voices, weaving harmony from separate notes. In this light, the story of zero is not only a tale of symbols, it is the journey of making emptiness useful. From placeholder wedges to a number with laws, from a merchant sips tool to a scholar sips anchor, from a quiet dot on a line to the still crossing of axes that frame a world, zero has always given language to where nothing rests. The still pond has its center. From that center, ripples spread gently outward, calm, clear, unhurried. If numbers can chart nothing, then lines can sketch its rules. Imagine an empty garden, smoothed by soft rain. The ground is still, the air hushed, and one by one you place stones with care, shaping a path. Euclid began in the same way, setting down a few small rules and letting them guide all that followed. The garden was never meant to be filled with ornaments, only to let a handful of stones quietly define the whole landscape. And with patience, those stones became the foundation of geometry. Euclid gathered the mathematics of Greece into a work called the Elements. At its heart lay definitions, postulates and common notions. Together they were the starter set for all that would grow. A point, he whispered, is that which has no part. A line is length without breadth. A straight line lies evenly with the points on itself. These are not measurements, but clarifications. A way of steadying the imagination so it does not wander too far. Then came the postulates. Gentle requests about what may be drawn, with only straight edge and compass. Draw a straight line from any point to any point. Extend a line, calmly, without end. With any centre and distance, draw a circle. Right angles, all equal to one another. And then, one final, careful request about how lines behave when a third line crosses them. Each postulate, modest in tone, but together they fixed the rules of play in the quiet garden. Beside them rested the common notions, broad, almost like soft philosophy. Things equal to the same thing are equal to each other. If equals are added to equals, the wholes remain equal. If equals are subtracted, the remainders rest the same. What coincides is equal, and the whole is always greater than the part. They do not mention triangles or points. They speak instead to equality itself, the background hum that keeps every step in tune. From these seeds, Euclid grew lines and angles and shapes. Congruence entered gently, when two figures could rest upon each other. He showed that when two sides and their joining angle match, the triangles match. Distance was the length of a segment. Angle, the opening between rays. Right angles, the steady benchmark. Step by step, he built a quiet toolkit. Bisect an angle, draw a circle through a point, erect a perpendicular. Nothing rushed, nothing loud. Every gesture calm and dependable. The most delicate piece was the parallel postulate. In Euclid's words, a careful mouthful about lines that lean, about angles that sum. Later softened into Playfair-Sipp's axiom. Through a point not on a given line, there is exactly one line parallel. From this, so much comfort flowed. Triangles, their angles always adding to two right angles. Shapes echoing each other across distances. The harmony of flat geometry, built on little more than whispers. The wonder of Euclid's work was how little he assumed and how much arose in quiet certainty. He did not measure. He proved, and proof in this silent garden was a meditation. Begin with what has already been placed. Take one careful step and another and another. Never rushing, never skipping, each conclusion arriving with the calm of inevitability. The Pythagorean theorem itself emerged not as rumour but as certainty, a natural consequence, unfolding when the earlier stones were already in place. This discipline, this slow, patient proving, became the model for science, a way to show that certainty can grow out of silence. And yet, questions remained at the garden's edges. Were the definitions fully rigorous? What does it truly mean for a line to have no breadth? For two figures to coincide? Euclid sometimes relied on the image in the mind, a triangle gently sliding until it rests atop another. Later thinkers noticed small, quiet assumptions, that circles of certain radii would always meet, that lines extend without end, that between 2 points, another always lies. Not absurd, but not stated. And the parallel postulate always felt different. Longer, less simple. For centuries, geometers tried to prove it from the others, only to find themselves back where they began. The attempt, though it did not reach its end, was still a gift. It showed us that Euclid's garden was not the only garden where geometry could quietly bloom, and yet within his walls the harmony remains, steady and serene. Congruence gives trust. Distance stays still, like a calm breath. Angles carry their quiet glow through clear glass. This consistency makes every step gentle, uncluttered. It lets a surveyor rest his mind as he divides land. It lets an architect lay a wall in its true square. It lets a navigator trust the stars, and a builder rest easy with a blueprint. Even when later methods grew broader or replaced certain tools, the rhythm remained. Begin with simple allowances. Justify each step. Carry conclusions forward, softly. Reading Euclid can feel like walking a silent colonnade. Propositions follow each other like lanterns, each one resting on the light before it. Sometimes a small flourish appears. A clever construction, a neat unfolding of length or angle, but even those flourishes stay gentle, like a garden path that curves just enough to reveal a new view. This serenity is not an accident. It is the shape that reason takes when it leans on very little. In that stillness, students learned a habit of mind. Do not assume more than you must. Say only what you mean. When two things are equal, whisper why. When two lines are parallel, show how you know. This habit trained generations to expect transparency from arguments in mathematics, and far beyond it. Even the rough edges had their lessons. Where Euclid leaned on pictures, later thinkers supplied axioms for betweenness, for continuity, for incidence. Where congruence trembled, they gave it firmer footing. Where distance and angle wanted clarity, they wrote careful rules. This tightening did not dim the glow of the elements. It revealed its lasting grace. Start small. Keep the rules simple. Let the structure carry itself. And again, there is the hinge, the parallel postulate, tying the garden to a particular flatness. If its words feel heavier, it is because they hold something that logic alone does not force. Change it, or set it aside, and the garden shifts its shape. Triangles may swell to more than two right angles, or shrink to less. Parallel lines may bloom into many, or disappear into none. The paths of shortest distance might bend, not just on the page, but in the very meaning of straightness. This is not a flaw in Euclid's SIP's design. It is a reminder. A few careful stones can frame one peaceful garden among many. So linger, just a little longer, in the calm he planted. Points without parts, lines without breadth, planes that stretch evenly, circles obeying their radii, angles like quiet gates measuring openings. Congruence keeps shapes honest. Distance keeps steps steady. Proof keeps the heart slow and certain. In a world that hurries, Euclid sets pace, invites deeper breathing. One lemma, one construction, one conclusion, then quiet satisfaction. Everything in this garden rests on agreements so small they can be spoken in a handful of lines, yet strong enough to hold centuries of thought. The achievement lies not only in the theorems themselves, but in the gentle unfolding, seeing so much arise from almost nothing. From simple definitions and allowances, space finds its form. From fairness and equality, measurement finds its trust. From a single hinge about parallels, The entire mood of the plane is set, and when that mood has settled, a final thought rises softly, like a question placed upon a stone. What if parallel lines refused to stay apart or never met at all? Imagine space as a vast fabric, laid out beneath starlight. In some places, the cloth lies flat, threads running calm and true. In other places, it swells like a dome, or dips like a saddle left in the rain. Walk across it with careful steps, and a surprising truth appears. The rules that once felt universal bend gently with the fabric. Distances follow new instincts. Straightest paths curve. The quiet sum of triangle angles refuses to be the same everywhere. Begin with a sphere, a familiar curved world. On a globe, the straightest routes are not the ruler-sipped lines, but the great circles. The equator is one, a meridian is another. If two cities lie apart, the shortest journey clings to a great circle, even if on a flat map it bows strangely. These paths are geodesics. The sphere sips straight the lines. The feet feel them steady as paper lines. Though an outside eye sees a curve, triangles on the sphere hold a gentle secret. Draw three sides on great circles, and their angles swell. Instead of 180 degrees, they grow larger, their excess rising with size. A tiny triangle near the equator barely notices, but a vast one, touching poles and equator, swells proudly with extra angle. This is no trick. It is geometry listening to curvature. The sphere sep's positive curve presses geodesics together, and the angles breathe wider. Airlines know this. Their routes follow great circles. Though on a flat map, the paths look arched. Sailors, too, have always known. A steady compass line spirals endlessly. But the great circle, changing gently along the way, is shortest. A truth revealed when you hold a globe and trace with your finger. Now turn the fabric the other way, and its tone shifts. Imagine a saddle, rising and dipping. This is hyperbolic geometry, curvature in the negative. Here, geodesics spread apart. Triangles slim down. Their angles, when added, sum to less than 180 degrees. The larger the triangle, the greater the loss. Space feels roomier, though eyes can scarcely picture an infinite saddle. In this world, through a point beyond a line, there are not one but infinitely many parallels. Lines that seem to walk together, drift apart forever. Even circles change. A circle with the same boundary holds less space inside than its flat cousin. The world seems to pull away from itself, making room where none was before. Grids fail here. Squares cannot cover the surface without bending. Instead, rich tessellations of many-sided shapes fit with quiet perfection. To see it clearly, mathematicians build models, bringing the infinite within reach. One is the Poincaré disk. Imagine all of hyperbolic space, packed into a circle. Its edge is infinity itself, never touched. The straightest lines become arcs and diameters, meeting the edge at right angles. Angles stay true, though distances compress near the rim. Another model, the upper half plane, shows the same world above a line. Geodesics here are semicircles and vertical rays, the boundary again an unreachable infinity. Neither model claims perfection. They hold the angles gently, faithfully, but they let go of scale, so that the whole picture can softly appear, and still they calm us. They invite us into the endless saddle and into the endless hush. of geometry quietly unfolding its secrets. Abstraction becomes a lullaby. Patterns repeat, tenderly drawn, inviting the eye to trace and rest. Artists once filled them with tessellations, fish, birds, ornaments, drifting smaller and smaller toward the edge, each one congruent in its true geometry, yet shrinking in our gaze. The mind drifts in the paradox, forever repeating, forever receding, forever, faithful to quiet rules of an unfamiliar space. Curvature whispers into our lives whenever we try to measure the world. Every map of Earth carries its compromises, because a sphere will not flatten without stretching or tearing. Some projections cradle the angles, keeping compass bearings simple, while stretching lands near the poles. Others cradle the areas, holding size true, but bending shapes into softer curves. None can hold everything at once. It is because curvature belongs to the surface itself. It is intrinsic, a property of the skin of space. No folding, no smoothing, can make a round world perfectly flat. Peel an orange and press it down. Cracks appear, and the peel insists on its own character. Navigators have long lived in this tension. A sailor, a pilot, each must choose what to preserve and what to surrender. If the path must keep steady bearing, a certain map makes the line straight, but lands swell and stretch elsewhere. If the path must be the shortest distance, another chart reveals great circles, while other features are gently blurred. Instruments, tables, and later algorithms grew out of these quiet compromises, practical tools, born of gentle arguments with curvature, and all of it returns us to a very simple feeling. The space between points carries its own mood. On a sphere, paths lean inward, embracing more angle. On a saddle, paths lean away, letting angle slip quietly out. Straightness is not in the mirror, but in the quiet rhythm of walking without turning. Even the idea of parallel becomes local, fragile, unique to its neighborhood. Two geodesics may begin as companions and then part softly, like a duet dissolving into two separate melodies. Circles whisper differently here, their circumference telling a story about the space that holds them. There is a gentle satisfaction in learning to hear these moods. Lay a triangle on a globe and feel its angles swell. Lay a triangle on a saddle and sense the angles ease away. In the Poincaré disc, lines bend like delicate arcs, yet still meet with perfect honesty. In the upper half plane, semicircles rise like lanterns, obedient to the rules of their world. The metaphors help, a fabric stretching, shrinking, breathing softly beneath starlight, shaping the steps of any traveller, and the facts themselves. They whisper gently too. Positive curvature draws geodesics together. Negative curvature lets them drift apart. What begins as curiosity becomes a quiet way of thinking. The mind no longer asks only, "What shape is this?" It asks instead, "How does the space itself behave?" It learns to listen to the fabric underfoot. Old theorems reveal their local roots. The triangle sets angles, once declared universal, become local truths. Lines once sworn eternal companions show that companionship depends on the world. Curved rules invite a deeper wonder. Whose curves are these? Picture yourself walking in soft fog. The ground feels smooth, familiar. Only a few steps ahead are visible. Walk long enough, and the path loops back, without sign, without warning. Each step seems straight, yet the world has gently closed. This is the lull of a manifold. Up close, it feels flat, ordinary, obedient. But in the distance, the whole reveals its quiet surprise. The lesson is soothing. The character of a place lives not only in each tiny patch, but in the way the patches stitch together. A manifold is a space that nearby looks flat, yet globally carries its own mood. Think of an ant on an orange. For each tiny step, the world feels flat beneath its feet. Angles behave as expected. But walk long enough, and there are no edges, only a round completeness. This gentle balance between local comfort and global personality makes manifolds perfect for dreaming about the universe. They honor our ordinary moments, square rooms, straight roads, steady angles, while allowing everything grand to be more than a flat floor. Once we see the local and the global apart, new questions open softly. Could space be infinite, stretching forever with no edge, or could it be finite, yet still without borders? Like the surface of a sphere, edges are not required for an end. A loop may close without a cliff. In such a world, a traveller could walk forever and return to the start, not by turning back, but because the path itself has wrapped around. In an infinite world, the path never returns. Topology is the language for these gentle questions. It listens not to angles and distances, but to connections. Two shapes may be topologically the same if one can be stretched into the other without cutting or gluing. A coffee mug and a donut share the same fingerprint, both with one quiet hole. Geometry and topology. They rest together like rhythm and melody. Geometry sets the local rhythm, distances, angles, curvature. Topology holds the tune. Loops, holes, connectedness. A space may feel flat nearby, and still globally folds softly into another mood. With this in mind, picture 3 calm possibilities for the shape of the universe. First, positive curvature, the 3-dimensional echo of a sphere. Finite, edgeless, a traveller looping endlessly. Second, zero curvature, a flat geometry, either infinite like an endless room, or finite if wrapped softly on itself, like a 3-dimensional torus. Here, moving straight ahead might gently re-enter from the other side. Third, negative curvature, the hyperbolic mood in 3 dimensions. Infinite, or finite without edges. If quilted together in careful seams, none of these require exotic inventions. They are simple, calm ways space may be, and if space wraps softly, its signature may show in light. Light may loop, offering more than one view of the same faraway place. Patterns in the oldest light may echo with quiet symmetry, like a melody returning in a new key. Light is the messenger, and listening to it is how we measure the shape of space. 2 gentle tools guide us: standard candles and standard rulers. A candle whose true brightness we know. We compare its glow to its essence, and the distance whispers back. A ruler, not a stick, but a pattern, stamped in the clustering of galaxies by ancient sound waves, rippling through a young cosmos. This scale leaves a memory, a preferred spacing of galaxies. Measure its size across the sky, and geometry begins to reveal itself, because curvature always touches how distance, angle, and brightness relate. The oldest light we can know, the cosmic microwave background, is a soft canvas glowing faintly, a gentle bath of ancient photons, released when the universe first cooled, when light finally wandered free. It carries a quiet speckling, tiny ripples of temperature, the seeds of everything we see today. And the size of these patterns is tied to geometry itself, a lullaby written across the sky. In flat space, the ripples spread in a certain way. In curved space, the paths of light bend, so that the same scale can look larger or smaller, depending on how space cradles it. By comparing these soft patterns to the size we expect, we arrive at a calm truth. The great expanse we live in is very close to flat. It accepts a quiet, cautious truth, for measurements carry uncertainty. Yet the mood is steady, almost serene. The observable universe is not bounded by walls, but by time itself, by how far light has travelled. Since the cosmic clock began, beyond that horizon may lie more of the same, or playful twists of topology we have yet to see. The absence of edges does not prove infinity, and circling back to a starting point does not prove finiteness. It only means that within the misty circle of what we see, the path is smooth, complete, and calm. Relativity enters softly, as the gentle rulebook through which geometry and physics whisper to one another. Here, space and time merge into space-time, a four-dimensional fabric, woven with its own quiet measure. Curvature is no afterthought. It is gravity itself. Matter and energy bend the fabric, and in turn the fabric guides. The drifting of matter and light. A beam of light bends near a star, not because a hand tugs at it, but because the fabric itself curves, and the straightest possible path winds softly with it. In simple words, matter tells space-time how to bend. Space-time tells matter how to move. We sense this curvature in quiet ways. Starlight doubling into twin images. Clocks ticking slightly slower near massive bodies. Planets orbiting with the faintest precession. Ripples of gravity passing through space-time like the softest tremor, stretching and squeezing space itself. Each effect is a whisper. Together, they hum one tune. Geometry is alive. Globally, it shapes whether paths close or stretch forever. Locally, it governs how rulers measure, how clocks beat, how light bends. Perhaps the universe is nearly flat, yet playful in its hidden topology. Or perhaps it is open, a tranquil expanse where every straight path continues, without return. Either way, the language of geometry allows the mind to rest between certainty and wonder, and so we return to the foggy loop for one last thought. Whether the path circles back or stretches on, the ground beneath is steady. Light traces its arcs. Clocks and rulers agree, and wherever mass gathers, the fabric folds around it with quiet grace. This is the wonder. Even emptiness takes shape. Even nothing has form. Imagine a river winding gently through a silent valley. Leaves float upon its surface, not tugged, but simply following the water-sip's flow. Gravity, in Einstein-Sip's vision, is like that river. Objects drift naturally, gliding along curves of space-time, without any force pulling them. Before this, gravity was thought of as a distant tug, mass reaching across emptiness. It worked well for falling apples, and for circling planets, but the mystery lingered. How can something pull across a void? Einstein eased the mystery. He showed that it isn't set of force at all. It is simply the shape of the riverbed, the geometry itself guiding every fall, every orbit, every beam of light. Free fall is not the absence of gravity. It is the purest expression of it. motion guided by the fabric alone, without any pressing force. To describe this precisely, yet softly, imagine distance and time woven together as one measure. A metric, a gentle rulebook, telling how rulers tick and clocks count. Where there is mass, the fabric dips and swells. That gentle unevenness is curvature. A planet circling a star is not yanked by a rope. It glides in the groove the fabric provides. Light reveals this best. From any point in space-time, imagine a cone of possibilities. The ways light can travel. Inside it, all possible motions for anything that obeys the speed of light. Outside, nothing can go. Near a star, these cones tilt and shift, ever so slightly. Time itself runs slower. Light loses a bit of colour as it climbs away. Subtle changes, barely noticed, yet faithfully recorded by precise instruments. When light passes near a galaxy, its path bends, not from a pull, but from the gentle shaping of space-time itself. The result: multiple images, curves and rings, the universe sketching itself through its own geometry. This gentle lensing does more than simply amaze the eyes. It does not shout, it does not rush. It softly confirms the quiet geometry of gravity and reveals the presence of hidden matter, even the mysterious dark that does not shine, yet still bends the fabric around it. The river picture rests tenderly here. An elevator drifts in free fall. Inside, objects do not crash or strike. They float, they hover, as though weight has melted away, as though gravity itself has fallen silent. But in truth, nothing has vanished. All are simply sharing the same gentle current, the same flowing fabric of space-time, for just a moment. A geodesic cradle, a peaceful ride along invisible lines. Step outside that small, still region, and differences slowly begin to appear. Two leaves may begin their journey side by side, but gently drift apart, or softly draw nearer, depending on how the river bends. In space-time, this slow drifting apart or together is tidal gravity, the most delicate clue that curvature is present. Gravity itself can be hidden by free fall, but curvature cannot be transformed away. It reveals itself in the changing relationships between neighboring paths. And so, a calm truth takes shape. Gravity is not a force reaching across emptiness. Gravity is geometry. The metric whispers to rulers and clocks how they must behave, how they must measure, how they must keep time. Geodesics quietly guide falling bodies, the way slow currents guide leaves downstream. Curvature encodes the presence of mass and energy, and it shows itself through tidal stretching, through time-sep's slow dilation, through the bending of light. What once seemed like action at a distance becomes something gentler, a quiet conversation between matter and the shape of space-time. And this conversation is steady, unhurried, polite. Matter arranges the fabric. The fabric carries all things along its quiet lines. This view does not crowd space with machines or pulleys. It simplifies. Where older stories required a force, leaping across emptiness, the geometric story only asks for a rule of measurement, and the patience to let that rule shift and soften where mass and energy gather. Far from heavy bodies, space-time relaxes into calm flatness. The old Newtonian rules return, still useful for planning orbits, still steady for bridges and roads, but nearer to compact stars. The curvature grows sharper, like cones leaning, and the differences cannot be ignored. Precision clocks feel the stretch, star-like curves enough to betray hidden mass. Ripples in the fabric, sent outward by colliding bodies, travel silently, lengthening and shortening distances as they pass. Hold the river image a moment longer. The leaves do not strain to find their way. The water carries them, without struggle, without noise. In the same gentle spirit, planets, photons, and even faint ripples of gravity follow the geometry before them. Once the shape is known, motion is no longer mysterious. It is graceful. It is inevitable. Zoom in closer. The vacuum is not empty at all. Picture it as a dark night ocean, under a thin silver moon. At first glance, it looks perfectly still, a black quiet stretching in every direction. Wait, and another truth slowly appears. Tiny ripples wrinkle the surface, then fade again. Faint patterns rise and fall, with no wind to stir them. In quantum field theory, the vacuum is this ocean. Fields fill every space, even when no particles seem to be there. What we call a particle is just a ripple of that field, a little packet of disturbance that can be counted, measured, and named. The ocean is never fully still, because the rules of reality forbid perfect stillness. Every field has modes of vibration, like a string holding its harmonics. In a purely classical world, those modes could sink down to silence. Zero motion, zero energy. But quantum mechanics does not permit that perfect rest. Position and momentum cannot both be fixed. The field cannot sit exactly at the bottom. There is always a faint jitter, a soft eternal murmur, called zero-point energy. It is not a surplus of fuel waiting to be harvested. It is simply the minimum hum, the quiet background tone, consistent with uncertainty. Sometimes, people describe this hum in the language of virtual particles. But one must tread gently here. Virtual particles are not tiny marbles, popping in and out of existence. They are symbols inside calculations, bookkeeping steps, a shorthand way of describing how fields affect one another, even when no visible particles appear. And yet, the vacuum sep's restlessness is real in its effects. A quiet, famous demonstration is the Casimir effect. Picture two flat, polished plates, uncharged, held very close together. Electromagnetic fields can vibrate in many ways, but the plates restrict which wavelengths fit in the gap, like a quiet instrument that only allows certain notes. Outside the plates, more vibrations are allowed. Inside, fewer. This difference creates a gentle pressure, a soft nudge that draws the plates together. It has been measured with care. No new forces are imagined. It is simply the way fields behave when boundaries are introduced. A quiet proof that the vacuum is not empty at all, but a medium with hidden structure. And yet, life feels calm and steady. Why, if the vacuum seethes? Because the ripples are tiny, fleeting, averaging out over ordinary scales. Only in delicate experiments, like the Casimir setup or subtle superconducting circuits, do they reveal themselves. And because large objects interact constantly with their environment, washing away fragile quantum correlations in a process called decoherence, the result is a world that feels classical, steady, reassuring to the senses. The ocean is still quantum, but from the shore it looks smooth. Zero-point energy sometimes tempts the question, if the vacuum has energy, Could it be tapped, like a hidden reservoir? The gentle answer is no. The vacuum is already the lowest state possible. Energy cannot be taken from something that has nowhere lower to fall. Quantum devices extract energy by moving systems downward from higher excited states, not by mining the ground itself. The vacuum hum shapes behavior, but it is not a bank to be drawn from. And yet, the restless ocean leaves traces. In atomic physics, the vacuum sips fields, shift energy levels, producing tiny measurable effects, like the Lamb shift. In condensed matter, engineered structures can shape these fluctuations, turning them into tools usable in technology. Each is not a wild storm, but a gentle conversation with the vacuum set's quiet ripple. As thought moves towards smaller and smaller scales, a careful image forms. At ordinary distances, space-time looks smooth, fields quietly doing their work. But as the scale shrinks, probing requires greater energy, and the neat division between fields and geometry begins to blur. Near the Planck length, around here 1 meters, classical ideas may fail. Geometry itself may tremble. Distances may blur, as though space-time itself is uncertain. These are not certainties, but open questions, patiently explored, maps still being drawn. For now, it is enough to hold the image of the night ocean, fields filling every corner of space, particles rising like countable ripples. Even in its calmest state, the surface never fully still. Uncertainty ensures a trace of motion remains. The Casimir effect whispers that boundaries reshape this ocean, pressing lightly on matter. The world feels calm because those jitters blur into smoothness. Because interactions keep large systems steady. Stand quietly at the edge of the shore. Let the night air settle around you. The faint ripples rise, wander, and fade beneath the moonlight. They seem to need no hand, no cause, no stirring breeze. Their origin is simpler than effort, because perfect stillness is never permitted. This is not a fearful law, nor a secret to exploit. It is simply the quiet way the deep ocean of fields keeps its eternal balance, always moving, always drifting, yet never breaking its calm. Now imagine a thread, smooth and patient. A bead rests upon it. If the bead slides into a loop, you may tug ever so gently, but it cannot escape. To free it, the thread must be cut, or the loop itself must be broken. That is the gentle mood of topology. Here, the game is not about sharp corners or strict angles. It is not about rulers or measurements or distances. It is about the way shapes remain connected, about the persistence of holes, about what can be softened, stretched, or kneaded without tearing. A friendly image waits in every kitchen, a solid coffee mug with a single curved handle. In imagination, knead it slowly, softening its sides, thickening its handle, until, without cutting or gluing, it becomes a donut. The bowl melts into the ring. The handle rounds into the body. The hole in the handle becomes the hole in the pastry. No new openings appear. None are sealed shut. Topology whispers, the mug and the donut are the same, for each holds exactly 1 loop that will forever trap the bead. A sphere, by contrast, has no such loop. Draw any band, any circle, any path across its surface. You can always shrink it, gently, quietly, until it fades into a point. Topology calls 2 shapes the same, when they can be stretched, bent, or squished into one another through smooth and continuous motions. These are homomorphisms, transformations without tearing, without cutting. And once cutting is forbidden, new measurements emerge, numbers that do not shift, no matter how much bending or smoothing takes place. They are called invariants, the soft fingerprints of connectivity. One is the genus, a calm count of how many holes a shape carries. A sphere, genus 0. A donut, genus 1. Two donuts fused together, side by side. Genus 2. Another is the Euler characteristic, a single number, a delicate balance between corners, edges, and faces. For familiar, gentle surfaces, this number is steady and sure. 2 for a sphere, 0 for a donut, -2 for a two-holed torus. And onward, the rhythm continues. Quiet and reliable, the exact formulas can be left to rest. What matters is the hush of their stability. No matter the bending, no matter the soft reshaping, these numbers remain unchanged. They are guardians of identity. From this focus on holes, a new way of reading paths unfolds. Draw a loop across a shape and see if it can be shrunk without leaving the surface. On a sphere, it always melts away. On a donut, some vanish. Others resist forever. A loop that threads the central hole, captures the bead. Count how many times it winds, and you find the winding number. A quiet integer, a permanent fact of shape, unchanged by gentle touch. Even the world of knots begins here. Though knots tie loops into space itself, the same principle sings. Some loops slip free, others remain tangled, beyond ropes and ribbons. These questions live in fields and materials. There, holes mark places where order quietly breaks, where patterns cannot be smoothed away. In a superfluid, or a film of a superconductor, the collective wave of many particles carries a phase, an angle-like whisper, read along a loop. If the phase winds once around, a vortex is born at the center. It is not mere energy. It is topology. The circulation is quantized. The winding number has spoken. You may move the defect, you may shift it gently, but you cannot erase it unless opposite windings meet, or unless the fabric itself is torn. Crystals tell the same story, but in their own accent. Atoms rest in a repeating lattice, orderly and calm, but sometimes a row ends too soon, or an extra half plane cuts in. These are dislocations, quiet scars that cannot be healed. By nudging atoms gently, the entire lattice would need to slide to restore perfection. Liquid crystals, the kind glowing in everyday screens, also reveal this truth. Their molecules prefer an alignment, a direction to lean, but at certain points, this preference twists, misaligns, and refuses to smooth out. These defects act as topological charges, labeled by how the molecules turn. As you walk a circle around them, even the hair on a sphere tells the same secret. Try to comb it smoothly in every direction, and some stubborn cowlick must remain. That impossibility is no accident. It is topology, hidden as a theorem. Electrons, too, fall into this embrace. In certain materials, their collective states carry a topological index. So long as the energy gap stays open, this index will not change. The shape may bend, edges may roughen, a little disorder may creep in. Still, the index holds, surface states remain, conducting at the boundaries, while the interior rests quiet. The details may drift beyond this soft stroll, but the refrain lingers, Count the holes, count the windings, count the absences that remain unbroken, and you discover behaviours that ordinary geometry misses. This counting of nothingness changes everything. For connectivity is destiny. It shapes what can flow, what can move, what can vibrate. Water in a basin with openings will follow paths you cannot guess from width and depth alone. A wave on a drum will sing patterns that depend on whether the drum has a hole. A charge near a hollow conductor will arrange patterns on its surface that remember the emptiness inside, even though the space holds nothing. Angles, lengths, measurements, they colour the details, but it is the presence of holes that decides the story itself. The bead and thread return. Slip the bead through a loop, and it is held, a quiet prisoner. Slip it around a small bump instead, and it slides free. The question is always the same: which entanglements last? Which vanish with smoothing? Topology answers patiently. A vortex will not vanish by whim. A dislocation will not fade with nudging. An edge state will not disappear, because a boundary was scratched. And so, very softly, all the threads begin to meet. Topology does not shout. It simply watches, quietly, to see what survives stretching, what survives bending, what survives the long smoothing out of edges. Homomorphisms whisper, reminding us when two shapes belong to the same quiet story. Genus and invariance keep the gentle memory of holes alive, like subtle marks in the silence of space. The Euler characteristic offers compact little labels for that story, numbers that hum softly in the background. Defects in fields and matter become the places where global order refuses to be flattened smooth. Their persistence is not arrogance, but careful bookkeeping, a quiet accounting of what must remain. Counting nothing may sound like a paradox, but in the hush of mathematics, it becomes clarity. It shows us what must stay and what is free to change, a way of finding structure in the stillness of silence. Patterns linger, even as details fade away. Symmetry. Imagine holding a simple kaleidoscope up to a soft lamp. Turn it ever so slowly. The colours drift, the shapes recombine, and yet the mood remains the same. That calm, steady presence in the middle of change is the feeling of symmetry. In science, symmetry is not decoration. It is not merely sameness. It is transformation that leaves the deep rules untouched. Rotate the stage, shift the scene, slide the hand of the clock forward, and if the laws still speak in the same familiar voice, then symmetry is there. It is the grammar of silence, the hidden structure that stays steady even as the scenery drifts. Think first about space. If the laws of physics are the same here as they are a single step to the left, then translational symmetry is present. If the rules do not mind which way the laboratory faces, rotational symmetry holds. If the rules today match the rules of yesterday and will echo again tomorrow, that is time translation symmetry. These are not small niceties. They are the very reason that experiments can travel, that predictions can be trusted. A pendulum swings the same. In every quiet room, a beam of light behaves alike. On a hilltop, beside the sea, or under the hush of a night sky. A century ago, Emmy Noether discovered something consoling. Whenever a system set's behavior remains unchanged, under a smooth family of transformations, a precious quantity is conserved. The statement is exact in mathematics. but its heart is gentle enough to hold in the mind. If the laws do not change with time, energy remains. If the rules do not change with place, momentum is preserved. If the laws do not change with rotation, angular momentum endures. Symmetry becomes a quiet promise, a steady assurance that certain measures will not fade, even while details swirl and shift. Like the kaleidoscope, shards may tumble, but the deeper balance never disappears. Not all symmetries live in space and time. Some belong to the hidden life of fields. In quantum theory, a field may be shifted by the same gentle twist everywhere, its phase tilted uniformly, yet the observable world remains unchanged. That secret sameness is symmetry, and when the twist is allowed to vary from place to place, new structures appear, quiet guides for interactions. These are the soft beginnings of gauge theory, where the demand that symmetry holds creates new fields, the fields that keep the balance intact. The words can grow technical, but the spirit is simple. When you insist on invariance, the world answers by weaving in new mechanisms that preserve it. Symmetry can also break, and that breaking can be creative. Think of water cooling into still ice. The liquid honors every direction. The solid chooses a pattern, a crystal lattice, favoring certain directions as special. The rules of nature have not lost their symmetry, but the state of the system has chosen. A magnet tells the same story. Above a quiet, critical temperature, atomic magnets drift aimlessly. Below it they align, choosing a single direction in space, and clinging gently to it. This is spontaneous symmetry breaking, and from that choice, new behavior emerges. Rigidity, patterns, excitations that behave like new particles, woven into the material. What seems like a loss of freedom is actually the birth of stability, the gentle opening of new possibilities. The thin line between symmetry and structure runs softly through daily life, like frost tracing across a window pane. Snowflakes form with sixfold grace, each arm echoing the others, because ice repeats its lattice in hushed regularity. Crystals in minerals carry the same echo. Their repeating motifs march through space, constrained gently by symmetry. Even the simple laws we trust bear this silent mark. The path of a ball in flight under a uniform field is predictable because the rules remain steady, unchanged across place, unchanged across time. Art and architecture. Read this grammar easily. A colonnade repeats its spans, inviting footsteps to fall into rhythm. A rose window turns a theme in circles, each rotation renewing the design. Minimalist rooms use symmetry sparingly, letting one axis line up air and sight. The calm we feel in such spaces is not chance. The body, the eye, the breath, all recognize invariance and softly relax. Music, too, hums this lesson. A theme that returns with inversion, with rotation, reassures the ear that a hidden rule is being honored. Sometimes the delight is in near symmetry. A pattern almost repeats, but leaves a gentle deviation. The mind notices the rule first, then the exception, and meaning flows from the tension between them. Nature speaks this language endlessly. Leaves spiral around stems, with near regular rhythm. Coastlines whisper fractal echoes, not perfect, but enough to carry the rule. Symmetry gives the baseline. Life writes the variations. In the silent background of all these stories, emptiness is instructed how to behave. When the vacuum respects symmetry, some particles stay massless, some interactions never appear. When the vacuum selects a particular state, masses can arise, new forces can enter. The stage is never blank. It has a weave, a quiet fabric of preference. We may not see the weave directly, but every motion across it is shaped by its invariances. The calmest way to hold this picture is to return once more to the kaleidoscope. Turn it. Let the fragments tumble. The mirrors keep their strict covenant. That covenant is symmetry. It explains why some things remain unchanged, no matter how the shards rearrange. It explains why new images appear when the covenant is nudged, when broken symmetry writes a new sentence. A gentle recap. Symmetry is invariance under transformation. From that invariance, conservation flows, as Noether taught. When symmetry breaks, patterns arise, new behavior is born. The world whispers constant echoes, snowflakes, balancing arcs, motion and stillness alike. Symmetry is the quiet rule, underneath both rest and change. It is the reason emptiness can have a personality, a structure, while still seeming unfilled. Even silence has design. So do empty rooms. Think of a white sheet of paper, a single brush stroke across it. The stroke is bold, but the quiet around it does most of the work. That silence, that soft margin, is what allows the picture to breathe. Emptiness is never just absence. It is always a frame, a quiet boundary that steadies attention and carries meaning. In the world of art, this hush is given a name: negative space. The eye does not only trace the dark ink, it also listens to the gentle intervals that hold the ink in place. Painters, designers, they lean on negative space, the way musicians lean on their rests. A figure is never defined only by its edges, but by the shapes of the gaps that cradle it. A leaning tree gains grace because the sky slips gently through its branches. A logo feels precise and still because the field around it remains calm. Gestalt psychologists noticed this long ago. The mind, in its quiet play, lets figure and ground trade places. A vase becomes two faces. Two faces melt back into a vase. The lesson is soft but powerful. What is not drawn can speak just as clearly as what is drawn. And the border between them is where perception awakens. In Japanese thought, there is a word for this pause, ma. It is the breath between things, the small interval that holds weight, the pause that allows one moment to fully arrive before the next begins. In a row of doors, May is the tiny courtyard that lets the feet slow and the light pour in. In a string of notes, Ma is the lingering echo that allows the melody to land softly. It is not emptiness. It is a charged pause, an alive waiting gap, where meaning quietly gathers. On paper, a calligrapher leaves Ma around the character, not by mistake, but with intent. The ink breathes, because the paper is allowed to remain paper. Minimalist architecture listens to the same intuition. Walls and air, proportion and light become enough. Instead of ornament stacked upon ornament, there is trust in what is bare. A quiet room, with clean lines and generous thresholds, does not lecture its visitor. It whispers, and the body unclenches. Tadao and Doceps poured concrete planes. For example, use daylight as if it were a building material. cutting seams of brightness that let the sky draw across the floor. Mies van der Rohe, with his soft phrase "less is more," echoed the same thought. When elements are reduced, their relationships sharpen. White ceilings, long sight lines, uncluttered corners. They hush the brain's constant labour to untangle busy patterns. Noise falls away. Attention drifts, then comes gently to rest. Silence has geometry, not only in sight, but in sound. Rooms carry a reverberation time, a measure of how long a sound lingers before it dissolves into the background. A space with hard, reflective surfaces can blur speech into a wash. A space with soft, absorbent ones can swallow sound too quickly, leaving the air strangely thin. The kind middle ground, where voices soften into murmurs without being smothered, is rarely an accident. Museums, chapels, libraries, they are tuned with care. Wood, fabric, textured stone, all chosen so footsteps hush and voices lower into warmth. Monasteries, over centuries, learned this by experience. A cloister wrapping its courtyard becomes an instrument. The echo slows, and so does the mind. Even an ordinary living room learns this lesson. A rug, a curtain, small tools that carve islands of acoustic calm. Museums show the same wisdom, in sight as in sound. A painting crowded by others drowns. A painting with a wall of its own, with space to breathe, suddenly begins to speak. Curators open long sight lines to a sculpture glowing at the corridor sep's end, or they break the sequence with a bench in a shaft of light. The so-called white cube, for all its critics, still holds one truth. The less that surrounds, the clearer the signal stands. Temples and shrines draw from this same well, though in different tones. A Tory gate frames only air and trees, and yet the body knows a crossing has occurred. A Zen garden rakes gravel into waves, and the emptiness between stones supplies the sea. An Islamic courtyard lays a pool of water, a still mirror where sky and geometry whisper to one another. In all these places, emptiness is not void. It is medium. It is partner. How does this emptiness guide feeling? Part of the answer lies in the body. The brain, forever predicting, tires quickly when overloaded. Empty regions ease the burden. Let the spotlight of attention settle softly. Edges become clear. Depth unfolds. Scale feels kind. Another part is learned. Culture whispers what to do with silence. A quiet foyer tells you to wait. A low ceiling nudges you along. A nave stretching long says simply, look ahead. Margins steady us. A white frame around text makes reading less effort. A white border around an object makes seeing less work. Designers use this with care. Frame a view, and the view deepens. Lower the ceiling near the door, raise it inside, and the body feels relief. Restrain the palette, and a single colour bursts alive. Align a table with a window, and the mind sighs with quiet order. None of this demands luxury. It demands only courage. The courage to leave space unfilled, the patience to let proportion do its gentle work. Even sciences, shyly, echo this lesson. In mathematics, emptiness is never truly empty. It is a set of permitted relations. In physics, a vacuum is not a void, but the lowest hum of fields, still alive with possibility. Emptiness, everywhere, is a stage, a canvas, a breathing pause that lets meaning arrive on time. So, does nothing have a shape? Hold up a blank canvas. It seems empty, but the frame fixes edges. The weave lends texture. The light falling across it sets a mood. The picture may be absent, but the conditions for a picture remain. That is a gentle way to hold the question. Does nothing have a shape? The answer shifts with the lips that speak. A painter whispers one, a mathematician another, a physicist a third. Each gaze is different, yet softly, all bow toward the same point. What we call nothing still wears a kind of form. It is the quiet frame that steadies all else. This frame has substance, not as matter, but as presence without actors. It can break symmetries, granting particles their very traits. It can set boundaries, nudging delicate forces into being. But it is not a bubbling broth of particles, not a noisy stew of events. It is subtler, rules without performance, readiness without motion. Because space-time itself is woven with geometry, the vacuum inherits that character. In general relativity, emptiness is drawn by equations of gravity, solved with little or no matter. Flat Minkowski space-time is the simplest canvas, a calm grid, light cones upright, rulers in harmony, but there are curved vacua as well. De Sitter space with its gentle positive bend, anti-de Sitter with its negative sweep, each with its own horizons and causal weave. These are not decorations brushed atop nothing. They are the statement itself. Geometry exists, even when matter does not. That is not nothing in the strict. Philosopher sits sense. It is an arena with laws, a canvas bare of scene, yet stretched, ready. Philosophy, too, asks us to take care with words. For words are not only tools, they are lenses. They focus thought, they bend it, they sometimes scatter it. And among the slipperiest of words is this one, nothing. In ordinary speech, nothing rarely means absence entire. We say, there is nothing in the bowl, but there remains the bowl, the air that fills it, the light that lets us see its curve. We say, there is nothing in the box, but the box itself endures, its walls holding space, its corners marking limits. Even in such everyday nothings, there is already much. Rules, forms, relations that permit bowls and boxes to be. But if we press the word further, if we try to let nothing mean literally nothing, no bowl, no box, no air, no light, no space in which a box might stand, no time in which a bowl might wait, no laws, no possibility, then the asking itself begins to fade. What shape could absence take? What position could exist without place? What duration could pass without time? Shape is relation among parts in space. Without parts, without space, the very question loses footing. It is like asking for the sound of silence, when no ears exist to hear it, no medium to carry it, no rules for vibration. Ancient thinkers saw this paradox. To them, true nothingness was less an object of knowledge than a shadow of thought, a negation to sharpen contrast, not a substance to describe. Language tempts us, always. It lets nothing masquerade as a name, as if it were a thing, a presence one might point to. But this is disguise. Nothing is a denial, dressed up as a noun, an outline pretending to be content. And so, perhaps, a calm synthesis is needed, If nothing means absolute absence, then it cannot bear shape. It cannot hold size or duration, cannot give location. It dissolves even as we attempt to grasp it. But if nothing means instead an empty arena, a cleared stage with no actors, then geometry may yet live there. Space without stars is still space. Time without events still ticks. Silence still has a tempo. Even the barest vacuum retains rules, retains the frame that makes prediction possible. In practice, the emptiness of science is never void, but fertile. It is alive with possibility, curved space bending around hidden masses, rippling waves of energy, light stretched thin as the cosmos expands, fields trembling in quantum rest. What feels to our senses like vacancy or silence still hums with law. It still carries a frame, and frames can be measured. The shape of nothing becomes then a shorthand, not a paradox, but a metaphor, the outline of the stage before the play begins, the presence of structure before the actors step forth. Think of a canvas, even blank. It is never infinitely blank. It has edges, fibres interwoven, a surface stretched with quiet tension. Its whiteness accepts light. Its grain resists tearing. Its plane invites pigment. The painter sees this not as void, but as readiness. So too with vacuum. Space-time is the canvas. Its metric, the hidden geometry, dictates the path of light, tilts the cones of causality, tells us what events may touch, and what must remain forever apart. Even a quantum vacuum, that most delicate of stages, retains its permissions, tiny quivers, symmetries preserved, boundaries respected. These are not ornaments. They are the ground rules. They are what gives science its voice. Without them, before and after lose meaning, near and far collapse, cause and effect dissolve into haze. But with them, with these frames, these quiet rules, these hidden metrics, experiments may speak, observations may sing, and the universe itself may whisper its story through light, through rhythm, through the steady geometry of what seems like nothing at all. And so the drama of modern physics is staged upon apparent emptiness. Light bent near galaxies, space swelling over cosmic time, tiny shifts in atoms. All are plays performed by the frame itself. The stage moves even when it looks bare. There is a quiet wonder here. Absence holds logic, and logic can be heard. Naturally, the question follows, is this frame fundamental or emergent? Are space and time the bedrock bricks of being, or only the wide-scale shimmer of something deeper? Quantum gravity whispers hints. Perhaps geometry arises from networks of relation. Perhaps distance itself is the echo of entanglement. Perhaps space-time is stitched from discrete threads that blur at vast scales. These are open paths, not settled maps. Mentioning them is only to mark the border between the charted and the still unexplored. Yet through it all, one distinction holds steady. A strict nothing cannot be shaped. An empty arena always wears its frame. The canvas waits, blank, yet held in tension. Threads run across, guiding strokes to come. Light and air lend context. Even the absence of objects rests upon these quiet givens. If nothing means this prepared openness, its shape is the pattern of rules that remain. If nothing means the absolute denial of being, then there is truly nothing to say. From the smallest quiver to the widest quiet, stand at a midnight shore, starlight above, tide slipping back. Step forward, and the edge withdraws again, always a few paces away. Cosmic expansion carries this same hush. Galaxies do not sail outward into some surrounding void. Rather, the fabric itself stretches between them. The ripples widen on their own. No center chosen, every shore receding all at once. And so the gentle question, if space expands, what does it expand into? No container is needed. The geometry grows by its own rules. The yardsticks themselves lengthen softly. Locally, life remains untouched. Atoms sit secure, bound tight by their forces. Stars swirl together in galaxies, gravity outpacing the drift. Only across enormous gulfs does the stretch whisper, and even there it is not violent, but patient, slower than a human life can notice. Because light travels with delay, this expansion inscribes horizons. One is the past horizon. Light from beyond a certain reach has not yet arrived. So the observable universe is a sphere not of walls, but of time itself. Look farther, and you look backward. The deeper the gaze, the younger the light. At last the cosmic microwave glow appears. The earliest page still legible, a faint ember from when the universe first grew clear. Another horizon belongs to the future. In an ever-expanding world, some events are too far. No beam launched today will ever arrive. That edge is an event horizon, not a fence, but a soft denial of contact forever. Horizons are not walls in space. They are relations between distance, no time, and the gentle pace of stretching. So arises the quieter question, what sets that pace? Observations whisper. Expansion is not only ongoing, it is quickening. Within Einstein's SIPS equations, the simplest phrasing is a cosmological constant, a uniform density, woven into the vacuum itself. Its role is not to push like wind, but to tilt geometry so that distances swell ever faster. In this sense, the vacuum carries a faint buoyancy. But let us be careful. This constant is not a reservoir to drink from, nor a restless froth of creation. It is a parameter, a calm term in the field equations, fitting observation with quiet precision. Other visions exist, but the constant is the gentle shorthand for what the sky reveals. Light, once more, is our messenger. Standard candles supernovae that burn with known brightness show how dimming carries the story of expansion. Standard rulers, the subtle patterns in the clustering of galaxies, reveal scale by their apparent size, and the oldest light, with its delicate speckle, adds a third voice. Its features project differently, depending on curvature. Read together, these voices sketch a horizon of stillness. The universe we see is astonishingly close to flat, a canvas stretched almost smooth beneath our instrument's sept patient gaze. This leaves wide possibilities. Perhaps it is endless, an infinite plane, quiet and unbounded. Or perhaps it bends back on itself, so gently that no survey yet can catch the curve, a hidden finiteness, folded too far away for our eyes. Large departures are unlikely. The sky SEP's own handwriting leans toward balance, yet even when the global page remains unwritten, the local script is clear. Light grazing a massive cluster, bends into arcs and halos, not glass, but geometry, scribbling luminous circles. From distant galaxies, each image a separate path, through space-time sep's gentle bow. On grand scales, galaxies drift, drawn apart by expansion, yet within their walls, gravity whispers. Gas cools, stars are born. Between them, emptiness swells. But this emptiness is no vacancy. It is a medium with laws, a horizon that moves with time, a shoreline of the observable that retreats and advances as light completes its long journeys. Infinity itself must be touched softly. Space may never end, or it may close upon itself, a secret loop beyond our reach. Either way, what we see is bounded, not because space is small, but because light has had only so long to travel. The horizon is a moving edge. Step by step, more of the early universe comes into view, even as far-off shores slip forever beyond contact. This picture is not fixed, yet it is serene in its unfolding, rules steady enough to predict, to map, to trust. Vacuum energy stands at the crossroads, a whisper finer than breath, the quietest murmur of quantum fields humming on the smallest stage. It is not absence, but a trembling presence, a soft pressure stretched across infinity, resting everywhere at once, yet barely leaving a trace. On the cosmic scale, that same murmur becomes the hand that nudges galaxies, a faint insistence that the universe is not only vast, but restless, still unfolding, still stretching, its fabric pulled taut in silence. Reconciliation waits, the full song not yet known, but even the small fragment already fits, a steady term, tucked quietly into the equations, becomes the key that unlocks the accelerating sky. Astronomers name it dark energy, yet what we measure is starlight sep's confession that the universe runs not toward stillness, but toward expansion. Return for a moment to the shore. Each retreating wave does not mean the ocean grows larger, only that its relation to the sand has shifted, that the rhythm between water and land has drawn a new boundary. So too with galaxies. They are not racing into a vast beyond. They remain within the universe, woven into its fabric, but the threads between them stretch and loosen, as if space itself were breathing in. This is the poetry of it. Relations stretching, not objects fleeing, and yet the precision lives beside it. Telescopes turn metaphor into measurement. Spectra of galaxies, tiny redshifts recorded patiently, become proof written in light. That space itself swells like a tide. Still, the quiet invitation remains to keep walking, to keep looking, to chase the horizon, even knowing it will forever step ahead. Expansion is not the departure of matter. It is the unfolding of scale. And horizons, they are not walls of existence. They are softer than that. Boundaries of vision, edges of what light has had time to bring us. Beyond them, the story continues, waiting in silence. For now, a constant term suffices, simple and calm, a placeholder in the equations. Yet deeper voices may one day sing louder. New fields, new symmetries, new rules of balance that whisper beyond today's sep's reach. The shape of the cosmos, so close to flat, yet never fully settled, still leaves wide margins. For mystery, perhaps the universe folds gently, in ways we cannot yet see, a subtle topology, like a hidden twist in fabric that only reveals itself when the cloth is stretched. Here emptiness is not ruleless. It is not chaos. It is a frame, gentle enough to cradle galaxies, steady enough to guide light, the kind of silence you can lean on. Let this quiet settle. Let it soften your breath. Numbers once marked absence, with the curve of a zero, a symbol so small, yet powerful enough to open mathematics to infinity. Lines and planes gave grammar to space, teaching us to describe the simplest stretches of nothing. Curves followed, teaching that even straightness depends on the fabric beneath it. On a sphere, triangles grow plump. On a saddle, they shrink thin. Then came Einstein, with space-time itself, bending gravity into geometry, transforming pull into flow. Planets became passengers. On a river of intervals, light became a swimmer, pulled along its bends. Quantum fields hushed further still, fields resting yet trembling, vibrations that never fully cease. Even in perfect vacuum, they quiver faintly, a ripple that cannot vanish, a reminder that nothingness is never truly silent. Topology arrived next, counting loops, measuring holes, showing us that space can twist and still remain unbroken. Symmetry entered too, its vows unchanging, a sacred grammar of laws that keep balance through every transformation. Art took these lessons in hand. Painters left margins of white so forms could breathe. Sculptors shaped stone by carving absence as much as presence. Architects echoed the same truth. Rooms hold us because of the emptiness inside them. Windows frame the world by the space they leave open. Then the cosmos itself leaned outward, its shoreline always moving, expansion carrying horizons, like a tide that never rests. And the lesson returned, gentle but firm. Rules can sketch even the soft outline of nothing, give a frame, a way to count, a way to compare, a way to connect. And silence itself reveals its shape. Even a bare canvas holds a weave beneath. Even still air holds pressure, waiting for sound. The frame does not crowd the world, it clears it. Emptiness becomes companion, a medium where meaning can appear. A page needs its margins, a sentence needs its pauses, a thought needs its breath. Carry that with you tomorrow. Notice the way a margin calms the page, the way a pause lends weight to a sentence, the way a window orders the view without adding a thing. The same clarity that bends starlight near a galaxy rests in the hush of a hallway. The same patience that lets space-time curve is in the quiet between two spoken words. Learning the geometry of nothing teaches the art of attention, to rest gently, to notice both what is present and what is absent. And so if this slow walk soothed you, know that other paths remain nearby, other walks through ideas where the noisy world softens and curiosity moves at the pace of sleep. You can always return, to drift, to listen, to let parallel lines finally meet in dreams, where rules are patient and angles are kind. Until then, let the day loosen its grip, let thoughts settle like dust in moonlight, and let the hush of the frame carry you gently the rest of the way. Good night.